This is my very first conference talk, so if I'm waffling or I'm nervous, it's because I am. But let me know, put a hand up, ask a question, slow me down. Whatever you'd like to do to get me back on track. We'll see how it goes. But good morning. Still morning. Welcome to my workshop on two things that I really find cool. And they're two JavaScript things that I find really cool, and they're Halogen and Elm. But I guess before I get too far into it, I should kind of give you a flimsy excuse why you may want to listen to what I'm saying up here. First and foremost, I guess, to start off with a joke, I'm a guy who desperately needs to update my LinkedIn photo. If you're a bit upset that you're getting the hairier and older version of Ben and you want to go to Mark's talk, I won't be offended if you kind of leave and that's what you're expecting, but sorry. I work for a company called Ephox, and we make one of the most deceptively frustrating things you can do on the web, and that's a WYSIWYG HTML editor. And we're masochistic enough that we have two of them. TinyMC you've probably heard of. It's the editor that sits inside of WordPress. Textbox.io is really cool. It sits in IBM Connections and Wickham, IBM Wickham, Web Content Manager. And they're both really cool pieces of tech, but they're both things that are really hard to get right. Andy will tell you all about it if you want to hear some war stories. I also coordinate the Brisbane FP user group. Up in Brisbane, we meet every month and it's good times. But as a programmer, I'm a stickler for abstractions. I really love abstractions that give my program just enough power for them to do what they need to do. But to not give them enough that I have to reason about things, about that piece of code, the power that they're not using. I guess some people would say that I'm an insufferable FP zealot, and I guess they're probably right sometimes. But deep down, I really love things that allow me to reason about my program better. And these things are things like algebraic data types, tracked effects, and especially the extensible effects that you're seeing in PureScript and other languages, maybe OCaml soon as well, that really get you to dig down into exactly what that effect is and reason about it a little bit more. I like things like classy lenses, free monad-based DSLs, and FRP. Lots and lots of good stuff. Because I love this stuff because most of my time is spent maintaining code and not actually writing new shiny stuff. And code that's easier to reason about is a lot safer to refactor and compose. And we're going to want to do that a lot as our code grows. And that's why I have absolutely no reservations about being super pedantic, maybe even inflexible about optimizing for that case. Because it's the thing that I spend the most time in, it's the thing that I get most annoyed at. So if that's better, then future me will praise all the pedantism that I've gone through to get there. I find that this is especially important for UIs, because they kind of bear the big churn of humans being inconsistent and not really knowing what they want until they see it. And over time, I really find that the UIs, they build up a lot of cruft because of this. And I think it's absolutely necessary that our UI frameworks help us reason and refactor as we go and to be able to do this safely. And that's why I actually work in the back-end teams at Ephox, but I really feel like any effort that will make this UI stuff more functional and more maintainable is super exciting and worth my time to get into it. And I want to help as much as I can. That's why I'm up here. So let's talk a little bit web UIs. Historically, we've not really had these nice things that we really want. But it is getting better, and that's awesome. But I think the biggest thing that I talk to people about where we are with this UI stuff is they kind of go, well, that's not very exciting. It's kind of just MVC with different clothes. They don't get the history and the pain that we've been through to get there. And I think it's important to go through this and to really see that it's getting better and getting better at a pretty quick pace, which I find exciting. So let's review this. I'm showing my age here. DHTML. In 1995, Mosaic came out with JavaScript. They wanted to make HTML more dynamic, and Microsoft got on board, and nobody could agree on what JavaScript was, and your pages only worked in one browser. But it was focused on the humble goal of just making that static page a little bit more dynamic, doing things like animations and validations and all that kind of stuff. But it was focused on the DOM, and all of our state was either in global variables inside of our programming language, or it was in the DOM. And in 2005, we made this worse. We started letting our JavaScript call to the back end rather than just be a little bit of JavaScript that made the HTML a little better. Our pages got more and more like apps. They got more complicated. But all of our state was kind of still in the DOM. And anybody who's worked on these big jQuery things, where you couldn't figure out where the hell anything was happening, and you didn't know where the state was, and why is that DOM thing still there? I thought it was going to be deleted. All that kind of thing, it was just a nightmare. It's this tangled mess of everything being in the DOM, and we didn't know where our business logic was, and it was just a mess. I'm glad to leave that behind. Then we created a different mess. We made things better. I joke, but we did make things better, but it just probably wasn't enough, not quick enough. But we moved to these sort of MVC-esque frameworks like Angular and Backbone and D3 and all these ones that kind of took the headache out of your business logic being mixed in with the DOM. We got rid of that and we separated it, which was really, really good. I was an Angular developer for, I don't know, 5 years or something. It was good. It was better than jQuery. But we're still progressing, and that's why we're here today to talk. Then in 2013, React came out with this fancy thing called Virtual DOM. And it gave us the ability to make really, really dumb views that were just a pure function from our state of the world to some virtual DOM representation where we weren't doing manipulation of the DOM ourselves. We were just saying, hey, this is what I think it should look like. React, go figure out what the DOM should be after that. It could diff and do all the fancy things to do the minimum possible changes to make that work. And React did some other cool things that kind of had this paradigm of minimizing this mutable state and favoring properties that are immutable flowing down the UI. And it really focused on making as much of the components in the UI pure as possible. So this was cool. I jumped into this, and this was exciting as well. But the mutable state, it kind of still was a hassle. It was still there in all the components. You didn't really know where it was. It could be anywhere. And it interacted really poorly with anything async. If you do a XHR off to the back-end server, it can come back anywhere and mutate the bit that it was supposed to. But that part isn't very clear when you're going into big code bases afterwards and trying to figure things out. So then in 2014, there's a star on these dates. They're a little bit of a lie, but don't let the truth get in the way of a good visualization. You'll see soon that it looks really cool. I think it was actually 2012 or 2013 that Elm was really created, but it's okay. It builds on this idea. It was obviously after 2013 because it was building on Virtual DOM, but it was building on this kind of idea of using Virtual DOM to have this DOM pure view of the UI. But it also did something really cool as well. It introduced types. It was a really simple language. JavaScript people kind of picked it up and said, hey, this is not too annoying. It's not crazy like Haskell. And people really got into that. Describing the events that can happen in a system with a closed sum type was something that really resonated with people. And that's a cool thing to see. And the thing that Elm did really well that React didn't end up getting, at least in its first incantation, was all of our async events that came out of things like XHRs or WebSockets or whatever, their effects came back into our program through a message type. So the message type that we described every possible thing that could happen to our state, these things were also happening and getting serialized into the pipeline of things that were happening both in our UI and from the outside world. So this kind of brought us to the nirvana of everything is pure. I just have this we'll see it later, but I just have this pure function from the old model to the new model, and I have a pure function from the model to the view. So it got us to a really good spot. But we'll see in a little bit that it's sometimes a little bit too simplistic for our needs. But moving on. This idea was so cool that React took it on board, and they made a thing called Redux. Redux is essentially what the Elm architecture is, just built into JavaScript and on top of React. And it's cool. We've got JavaScript people talking about pure functions and that they're awesome, and that they should manage their effects and things like RxJS. And they should even use types. People are using Flow and they're using TypeScript to have this sort of type system that can say, my event is either this or this or this or this, and be able to reason about it. It's a bit of a shame that these type systems don't quite work as well as they should, but it's good to see people moving towards that idea that types are cool and pure functions are cool. I get really excited from seeing this. I also get really excited when my sort of pure functional programming zealots take these ideas and run with them further. And the library that I want to talk about in both the talk today and in the workshop is a pure script library called Halogen. It basically takes the Elm architecture and runs with it, but having a better type system with a few extra functional goodies allows it to run a little bit further with the idea, which I think is useful, and it's worth the additional rigor and learning curve to get there. Not everybody will feel that way, but I mean, that's what my workshop's about. It's about coming to the workshop and doing something side by side and going, hey, Elm's probably right for me, or this other thing's pretty cool and it's worth the extra trouble. Well, at least I hope people take that away. I think it's an incredibly cool time to be in this space. It feels like we've ironed out a lot of the bad issues and really gotten to that point where we have this functional core of the idea, and it's just about making the abstraction work for us at this point and making it as least boilerplatey as we can. And that's incredibly exciting for me, and especially that it's kind of gotten to the point where it's capturing the attention of people that didn't really feel like they needed types or this kind of rigor as well. There's obviously a core to this idea that is really resonating with people, and I like these kind of ideas because it means that the general ideas of functional programming might spread a little bit and become more normal. And I might not be just the weirdo who codes in Haskell and nobody wants to work with. That is a really cool thing that maybe one day I won't be weird, but I'll find something else to be weird about, I'm sure. But why would you care? And I guess the thing that I think everybody should care about this browser stuff is that whether you like it or not, browsers are becoming the UI of choice for most people. You just have to look at the two newest editors that are hot. They're both Electron apps, and people want to write Electron apps rather than doing sort of system-dependent GUI libraries or anything like that. I don't think we're not going to be able to get away from programming like this, whether we're trying to code for the desktop or the web. So it's probably going to happen to us whether we like it or not. So we may as well jump in, get excited, and make this as functional and as palatable for us, and to really help the things along as much as we can. So let's talk a little bit more about Elm and Halogen. How am I doing for time? Cool. Elm, as we've talked about, it's a purely functional UI language. Compiles to JavaScript. Doesn't have any mutation at all. All the mutation that happens from your UI changing state is not handled by your code. It's handled by your update function giving a new result to what the state of the world is, and then that being stored in somewhere that you don't have access to. It has tracked effects, which is awesome. I mean, to get to a purely functional thing, you need this. So it's really good to see even a library that's aimed for complete simplicity and being as beginner-friendly as possible has still taken the effort to make effects tracked. That is a very cool thing to see in that kind of space. It leans on virtual DOM.
And it looks a little bit like this. And this is the awful diagram that you probably won't be able to read from back there. I'm sorry, I didn't test it until now, just before. So this is the general shape of things. And you don't really need to see this text here because all it is what it's the same thing as the text here. So this is our view of the world. We have our simple, dumb view, which just takes it takes our model type and generates a representation of what the UI should be. It's as simple as that. And then Elm will go ahead and do whatever updates that it needs to make it happen. Let's ignore, we obviously, if we start our program, it needs to start off with some kind of initial value. Cool. I'm going to talk about that in the next slide, so let's talk about it. So let's go back for, whoops. So I guess the general shape that I want to talk about before I move on to the more detailed slides here is the bits that we have here, and I've said it before, it's good to rehash it because I think this part is the cool part, that everything that we do, all the bits of code that we are writing are completely pure. We have our view, we have our model to get the new state of the world, and then we have all the possible things that can change in our system defined by a completely closed sum type so that we can reason about that and know exactly all the possibilities. There's no, oh wow, this thing right down here in the code did this weird update that we didn't expect. It's completely defined by this sum type and nothing else can happen. So, moving through in details. Obviously with our UI, we have to construct an initial value. We kick off things, and then optionally, if our UI needs to do some kind of back-end call to get some more data or whatever, it will optionally put in a command which is just a request. It's not actually doing the effect, it's just, I'm going to ask you to do this XHR call, can you please do that? And when that call happens, whatever parsing of the JSON or whatever is encoded into that command will eventually parse it into your message type for your program and then feed it back into that cycle. So it'll come back into your update function, do whatever state updates you need to, and then the UI will regenerate. We talked about the view to death. We probably don't need to talk about that much more. The only thing that's interesting here when we're looking at it in details is that our HTML is defined by a type parameter here. And this is just like command and subscriptions, where the side effects that are raised from our inside our HTML, so clicks and mouse movements and whatever things they raise back to your program have to be in this message type. So again, we're kind of using that to very much restrict and be able to reason about exactly what's going on and know that our update can handle every possible update that's coming in our system. And our update, we take a message, we take the old model, and then we return a new model, and optionally, a command to do. So if there was a button clicked, and by clicking that button we have to go off and do a back-end call, then that's what gets encoded into that command. The other thing that we have are subscriptions. So a subscription is any side-affecting value that's going to come into your program that you didn't explicitly ask for. So, well, you did ask for it, but you didn't initiate that message coming in. So anything to do with WebSocket inputs, or what time it is, or any external JavaScript communications in, because it has an event it needs to tell you about, will come through this subscription. And all of this is just a list of possible subscriptions that Elm needs to maintain and care about to make these messages flow into your program when they need to. This is all beautifully simple, and I think that's why people have gotten into it and have picked it up so easily. It's a very easy thing to just pick up and run with and do very simple examples with. But it's probably a little bit too simple, depending on what you need. Maybe it's what you need. I hit the edges of it, but that's maybe because I try and do crazy things because I'm used to Haskell. But the biggest problem that I have with Elm is that that top level thing, the program, which was the update function, the view, the initial value, you can't compose those things. So you can't take a program and have another program and then have a bigger program out of those. What you actually have to do is you have your top level program and you're just manually wiring these things together yourself, which means that you could do something really stupid like forget to wire in the update part of your subcomponent and have those things not actually happen. You can do really, and I have done silly things like that where I've forgotten to wire things in. I've essentially had a no-op, and things that I expected the child component to do weren't happening, and that was my fault. And to me, that seems a little bit broken. And the model and message types, so as you kind of compose your functions together, these get bigger and bigger and bigger. And they hold a lot of stuff in there that you probably don't want to care about as the parent. Like, if you were making a form field that was validating whether it was valid or not, and you had little internal checks of did it pass this regex or whatever, you don't really want your parent component dealing with that or even having to look at that. There's a lot of noise that happens in the model and the messages too that maybe parents don't want to care about. And to me, this kind of lack of modularity feels like it would fall off the rails as soon as you start getting bigger and bigger. And other people have had this kind of effect and have felt this way too. So it's probably not just me, but if you can go either way on that, the workshop should sort it out for you. The other thing is that our commands, so that when we go out and do an AJAX call, the message coming back in has to be a new constructor of a message. So the message can be very noisy with basically details of the steps internally of what needs to happen when we go out to the outside world and come back. An example of this is like a button that goes and loads a file. You might have a message to say, hey, I clicked the button. That's the UI event that comes in from the HTML page. And then you would go off and do your command, and the command would either, based on whether it was successful or whether it was an error, it would either come back with an event that said, hey, I was okay, and here's your file data, or hey, this doesn't work, and here's an error message. That kind of, if having that for every kind of backend call that you did, can get a bit tiresome after a while. And there's a lot of stuff in there that you probably don't want to see in the sort of parent level of, I'm looking at this message and trying to figure out what its public API is, because you may not care about this thing. It may have already put an error message to inside its little DOM element or whatever. Not being able to separate those kind of internal messages from the public ones seems to be, in my mind, is a pretty big problem. Some people may not be upset about this, but I am. Command is also not a monad, so you can't sequence these things. There is a combinator that says, I have a list of commands and go off and do them in parallel, so it kind of has applicative. But if you have a sequence of things that says, I need to do this command, and based on the results of this, do this command, and based on the results of this, do that command, you basically end up having to write a little state machine in your update function. And that's really annoying when you could just have a monad. As a functional programmer, that kind of makes me mad. Because there's a simple, well, am I really going to say there's a simple thing that is just monads and people can just use that? I'm kind of making fun of myself, aren't I? But there is an abstraction for this. And I hope they get there eventually. It feels really awkward to get into this state. And I don't have an example of this in the workshop, but I can, 5 minutes? Sweet. But if someone wants me to write up an example of this, I can. Elm could work for you, and it seems to be working for a lot of people, so maybe it's fine for you. But to me, in my functional brain, feels like there's room for improvement. So we have Halogen. It's a pure script framework that compiles down to JS, is purely functional, has virtual DOM stuff, is based on events flowing into an eval function and that pure view. And if you squint, it looks a lot like Elm. But it has some very cool tricks that I think fixes a few things with Elm. It has a monadic eval. which allows you to sequence these back-end calls. And if one fails, then you don't need to kind of write your state machine in your eval function. You can just use what monad is for and have a tree of computations. And this allows you to kind of batch up your units of work for your UI and not kind of confuse the public API and the internal inids of what it's doing. It also has nested components where you can't forget to wire things up. It's just there as part of the abstraction. An abstraction where you can forget to do something is probably not a good abstraction in my eyes. And having that automatic is a lot better. And this one is a bit controversial. The state of the component is completely hidden within the component. So you don't have this big model that builds up as you kind of get higher and higher. So what it means is you can't dig into the inids of a component and break the invariance of what it's trying to do with its abstraction. But what Halogen does allow you to do is it allows you to ask for the state of a component. So if a component wants to give you access to a certain part of its state, it can write a query that will allow you to get that value back. And that's also really useful for some other operations where it may not be performant to get an event back every time. You may want to learn of a new value. A really good example of this is a text editor, where a parent that owns the editor probably doesn't want to get an event every time someone types in something into the editor. But it may want to ask for that content when it's going to submit a form or whatever. So that particular thing, I find it kind of ties that knot of if you just have signal-based FRP, you get yourself into trouble. And having behaviors where you can poll the state of something in the world really gives you that performance leg up. But this extra power doesn't come for free. This is the diagram for Halogen. We'll talk about this more in the workshop, but it's just allowing things to be nested with each other means that there's inputs, there's outputs, and the inids are a bit more complicated, but don't worry about it too much. And the type is downright terrifying, I guess. There's a lot there. And I mean, this is the reason why people don't just pick up Halogen straight away. That looks scary, and you might need to burn yourself on Elm before you realize that this might be a good idea. And hopefully, you might think this is a good idea after coming to the workshop. So quickly going through, I think we're about to finish on time. The workshop's going to run so that we kind of implement the same idea in Elm and Halogen side by side so you can figure out what sucks and what doesn't and what works for you. And hopefully it should give you an idea of the differences and help you make that decision. And you can either yell at me and heckle and say that I'm silly, or you can agree. Both are good options. So what you will need is you'll need some code checked out. And you'll need PureScript, Pulp, Bower, and Elm. There is instructions in the installation thing here if you haven't already done that. And Visual Studio Code is pretty handy. It just works out of the box with installing a few extensions, and it gives you a pretty good behavior. I'm going to be in this room all lunchtime, so if you haven't got this set up and you need a hand, just come find me. It'll be better if you do that while the room's relatively empty rather than when it gets crazy. And thanks.